Hello everyone, welcome to the next lecture on the CSIR net mathematics. Today I will explain you how you can solve the boundary value problem or particularly called as the Sturm level problem. Myself Dr. Harish. You can follow my YouTube channel where you can find the playlist of the CSIR UGC net. You can subscribe my YouTube channel as well. You can find the various PY question series related to the CSIR net and the GATE examination all with the help of the shortcut tricks. So let's start with this lecture. So before I directly move on the PY questions, let me quickly recall you the simple concept and the various shortcut tricks so that you can solve each question with the help of the 10 to 15 second time period. Kindly subscribe my YouTube channel for more updated videos. So what is the concept of the Sturm level problem? Any of the differential equation of this form is called as the Sturm level problem, subjected to some condition, and that condition is applied on this interval a and b. That means if I call alpha 1, alpha 2, remember it's a negative sign for this lower limit while the positive sign for the upper limit. And these alpha i's or the coefficients p, q and r are the continuously differentiable function. This r is my weight function, and now since it's a differential equation, so it must know that p of x should be non-zero and each of the alpha I are strictly greater than 0. Make sure it should be the negative sign. Then if I consider the particular case, that means if this value are at the endpoints a and b are same and 0, then you can say the problem is called as singular, because we all know what is the meaning of the singular, where the singularity occurs. That means p of x should be 0. On the other hand, if both the p of a and p of a are equal, but it may or may not be 0, and the other values are p, q and r, all are my greater than 0, then we call as the periodic boundary value problem or periodic Sturm level problem. And the last case, if I call as p and q, p and r both are my positive, whatever the value of the q can be positive, it may be positive or it may be negative, then we call as the regular boundary value problem. Now remember that the one of the most important concept that is very useful for the CSIR examination, GATE examination, NBH examinations, as well as your MH set examination or any of the examinations. Whenever you have the differential equation of this, then this lambda must be the constant, fine, or this lambda is a function of x. There are the two cases. So I consider the type 1 firstly when your coefficient of the y is my constant and it is a positive. Whatever the boundary condition is given to you, then the solution will always be the form of y is sine of root lambda x. How you can find the lambda? Now look at the cases. Take L is my length of this domain. If y of a and y of b are 0, then your lambda will always be my n pi over L whole square, where L is my b minus a. So clearly say this value, because it's a square, n is my positive number, so that number will always be greater than 0. That means it is always be the positive number. Similarly, if you have the endpoints are same and the derivative is also same, then your value of lambda will be 2n pi divided by L of whole square. Make sure n must be the positive number. So from here lambda you can substitute this value, you can get the solution of this boundary value problem. Third case, when y of a is equal to y dash of a and y of b is equal to y dash of b, like of here. In this case the endpoints are same and derivative also same, while in this case endpoints are same but respective of the value and its derivative. Then the solution is n pi over L whole square. And the last case is whenever only the one condition is given to you, y of a and the derivative is 0, then it will be the odd multiple of this. So clearly say n is equal to 0 also satisfied because it is a non-zero, so I can consider 0 as well here. In all the cases you can find the value of lambda and the respective solutions, and make sure based on these 4 values, 4 shortcut tricks, you can solve each question with the help of the 10 to 15 second time periods. You can get more of these such kind of the shortcut tricks we will see in this lecture. First of all, clearly say this is the boundary value problem, and What is the domain is 0 to pi, and both the values add 0. So what is the case of the lambda? Lambda is n pi over L whole square. What is my L? L is my b minus a. Pi minus 0 is pi. So if I substitute here, lambda will be n square, where n is my positive natural number. But he said negative. Cancel out. Root of n, but we need a n square. This option is cancelled. It's a n square and n is my positive integer satisfied. On the real r, it's a wrong. Right answer is C is my correct answer. And you can see you have to write only the 2 lines and you will get your answer in a simple manner. Okay, look at this another one. What is given to you? Y double dash plus lambda square of y is my 0. And you have a non-trivial solution. Y of 0 is y of pi and y dash of 0 is y dash of pi. So that's again the shortcut tricks. What is the L? L is my b minus a. So the lambda will be 2n pi over L whole square. Now in this case, lambda is my lambda square because it is my coefficient of this. So if I substitute here, L is my pi, pi will be cancelled out. It's a 4n square. And I need the value of lambda. So what is the value of the lambda? 2 of n. N is my positive integer. So 2n, n is my positive integer is the right answer. What is given to you? Y double dash plus lambda y is my 0. Y at the initial point is y at this point. Y dash at the minus and y dash at here. So can you calculate the L? B minus a, that is my 2 pi. Fine. So again you can see the same trick. Y at the end points, y dash at the end point. Solution will be 2n pi L. So the lambda will be, in this case lambda is my here 2n pi divided by 2 pi. So the solution will be n square, where n is my positive integer. So only one eigenfunction wrong. What is eigenfunction? That means the value of the y, sine root lambda x. Fine. So always get the 2 eigenvalues or 2 eigenfunctions. That's option correct. And remember, whatever the eigenvalue you have obtained, this corresponding the solution, that is a y, is my Li. This is my orthogonal. Fine. These are my Li. These are my orthogonals. So Li satisfied. Orthogonal eigenfunction, that's the value of y, is the right answer. Always remember, this is the set of the eigenvalue is my countable. Fine. So if they are asking about whether the set is countable or not, you can take about here. So the right answer is B, C and D are my right answer. Okay, what is given to you? U double dash plus lambda of u is 0. Initial condition is that u of 0 is my 0 and u of dash pi is my 0. What is the meaning of that? You can see y of 0 is 0 and this value is given. So what is the meaning of that? This value of lambda will be odd numbers of this 2n plus 1 pi over L whole square. Fine. What is my L? B minus a. Pi minus 0 is pi. So that means I can see n plus half whole square. L, pi will be cancelled out. So lambda will be here, and in this case n is my positive integer and 0 also, because if you take it as a 0, it is still positive. So there exist the eigenvalues and the corresponding eigenfunctions are orthogonal. That's the correct option. There exist eigenvalues. Fine. Look at this another one. If the eigenvalues are k plus half, that's n plus half whole square, with the corresponding values sine root of lambda, that is n plus half of x, and you can see this is also the correct option. The eigenvalues are k plus 1 whole square, but we need a k plus half of whole square. There exists no real eigenvalue, but these all values are my real. Right answers are A and B are my correct answer of this problem. And you can see all these shortcut tricks I have explained here. You can change also this value as y of a is 0, y dash of b is my 0. Apart from this, you can change them as here. Okay, look at this another one. I can write this again a boundary value problem. So I can say u double dash plus pi square u is equal to 0. U of 0, u of 1 is my 0. So what is the L? B minus A. Fine. What is the value of lambda? Again, in this case, lambda is already calculated. But you can see what is the value of the lambda. N pi over L. L is my 1. So it is my n square pi square. So in this particular case, n they have taken 1. So what is my solution? Solution is sine root of n is my 1. So that is a pi x. Fine. Now this is my solution. Now look at the first option. 0 to 1 sine cube pi x dx. How you can integrate them? I can use the formula for the sine of 3a. So sine 3x will be 3 sine x minus 4 sine cube x. So it will be 3 sine x over 4 minus sine 3x over 4 into dx. Fine. So it is my pi x. So I can written this number is 3 pi x. Fine. Now what is the integration of this? 3 over 4 is outside. Sine integration will be minus cos pi x over pi from 0 to 1 minus of this. So clearly say when you substitute 1, it is my sine 3 pi x minus minus plus over 12 pi from 0 to 1. So this number will be 0. Fine. This number cos of pi will be minus 1 and cos of 0 is, so it is a non-zero, but he said 0. So that option is cancelled. Now look at the second option. So let me clear the screen. What is the second option is u dash square. What is the u dash? Is pi cos of pi x. So what is the u dash square? Is pi square cos square pi x plus pi square u square. What is the u square? Is sine square. So what is the right answer of this? So pi square is common into 1. So what is the u dash square? What is the value of this? U dash at the point 0. Cos 0 is 1. Cos 0 is my 1. So it's a pi and it's a pi square, which is written as u dash square. So that option is correct option. Third option, the left hand side is same, that is a pi square. Your left hand side is my pi square. What is the right hand side? U dash at the 1. So what is the u dash at the 1 is minus pi, and if you put it as a square, it is again pi square. So that option is also correct option. Look at the last option. Integration u square. U square will be sine square of pi x, and the right hand side is 1 over pi square derivative square, that is a pi square cos square pi x of dx from 0 to 1. So this value will be cancelled out. So what is the integration of this? Or you can use the orthogonal property. If you are using the orthogonal property, this number will be half. Orthogonal property of the cos square is again half. So both are same, it is equal. Otherwise you can write it as this and integrate them from 0 to 1, it is again half. So the right answers are B, C, D are my correct answers. Okay, look at this another one. Again u double dash plus pi square of u 0, and the value of this at the end point is my 0. It is clearly say lambda will be my pi square. Fine. Again you can see that value you can compute it as n pi over L whole square, because the end points are same. L is b minus a. So clearly say it is n square pi square. In this particular case n I have taken 1. So u will be sine root lambda, that is a pi x. Fine. Now look at the first option. U dash square. So pi square cos square plus pi square sine square of this. So it will be pi square. This LHS u dash square. What is the u dash is? Pi cos of pi x. So clearly say u dash of 0 is my pi, which is a pi square. So first option is the correct option. Look at this another one. Second option, 0 to 1 u dash square, that means pi square cos square pi x minus pi square 0 to 1 u square. What is the u square is? Sine square pi x of dx. So by using the orthogonal property, this answer will be half and it's a pi square. This answer is half. So this will be 0. Satisfied. Look at the third option, u dash square. What is the u dash square is? Pi square cos square plus pi square u square, that is a sine square. So what is the answer of this is? Pi square, but he said 0. So that option is cancelled out. This number is similar of this. The only right hand side instead of the 0, it's the u dash square. What is the u dash square at the 0? Is a pi square, but we need a 0. So that means this option is cancelled. Right options are A and B are my correct answers of this problem. Okay, look at this another one. Y double dash plus lambda y is given to be here and the value is given to be this. Value at the derivative is given to be here. What is the value of the L? B minus A, that is 2. So what is the value of the lambda? 2n pi over L whole square, where n is my positive natural number. So this is my 2 will be cancelled out. So that is n square pi square. Fine. So all the eigenvalues are strictly positive. Yes, because n is my positive number, it's a strictly positive. All the eigenvalues are my non-negative. What is the meaning of the non-negative? Non-negative set is a positive and 0. Fine. But clearly say because n is my positive natural number, lambda is always be strictly greater than 0. So that option is cancelled out. Since n is my positive natural number, so each of the eigenvalues are my distinct. Fine. These are my distinct eigenvalues. So and distinct eigenvalues are orthogonal to each other. The sequence of the eigenvalues. What is the sequence of the eigenvalues? It's a pi square, then 4 pi square, then 9 pi square, and so on. Fine. Is it bounded above? No. It is bounded below, but unbounded above. Fine. So this option is cancelled. Right options are A and C are my correct options. Okay, look at this another one. Y double dash plus lambda y is 0. Y of 0 is 0. Y of pi is my 0. So what is the L? B minus A. So the value of lambda will be, again endpoints are 0, n pi over L whole square. L is my pi, so pi will be cancelled out. It's a n square, where n is my positive natural number. So there exists only the countable many characteristics value means eigenvalue. So yes, as I told you, eigenvalues, the set of the eigenvalues are always be a countable. Fine. So this is, and it is uncountable, cancel out. Each characteristics function, that means the value of the y. So y will be sine root lambda, that is nx. Fine. Each characteristics function corresponding the value has exactly this much zeros. So you can see, if I simply take n is my 1, what is that? It's a sine x. Fine. This value is my, now the interval is 0 to pi. How many zeros in between them? It's open interval. How many zeros in between them of this function y? There is no 0. Fine. So it means whenever n is 1, number of the zeros are my 0. But he said when lambda n is equal to 1, when n is 1, what is the value of lambda? Lambda is 1. So when lambda is 1, it's a 1 minus 1, 0. and it's a 1. It's a wrong option. Fine. When n is equal to 2, then your lambda will be n square, that's a 4. Then solution will be 2x. So sine of 2x will be up to here. How many zeros are there? Fine. So up to, because it's a sine of 2x. So can you draw the graph of the sine 2x? This is the graph of the sine 2x. How many zeros in between them? From the 0 to pi? 1 0. Fine. So whenever n is 2, number of the zeros are my 1. And you can see lambda is my root of lambda. Root of lambda is my 2. 2 minus 1, 1. So that's the right answer. So A and C are my correct answer of this problem. Okay, look at this one. Again, this is given to you. What is my L? Pi minus 0 is pi. End points are my 0. The value of lambda will be n pi over L whole square. What is that? L will be cancelled out. It's a n square from positive integer. So no value of lambda cancel. Can you return 1 as a square? Yes. N is a positive number. Yes, satisfied. Lambda is the n square. N is my greater than 1. So whenever n is greater than 1, that means 2, 3, 4, it is always square. It is cancelled out because he said equality 0, but 0 does not satisfy this property. So the right answers are B and C are the correct answers. Okay, look at this another one. Now you can see about this property. This is x raised to power 4 y dash and again the derivative. Fine. Plus, now what is that? This is a Sturm level problem. Remember what I told you in the initial case. This is my plus q plus lambda times r of y is equal to 0. That is a Sturm level problem. Fine. Now if you compare them, this is my p. Fine. What is the q? If you compare them, q will be 0, r is my 1. This is my continuous function. Fine. 0, every constant function is my continuous function. So property satisfied. So what is that? And what is this coefficients? 1, 2, 1. All are my strictly greater than 0. So what does it mean? It has a Sturm level problem. And Sturm level problem has eigenvalue always greater than 0. All the eigenvalues are negative. Cross. All the eigenvalues are positive. Fine. There exists some negative eigenvalue. Cross. There are no eigenvalue. Cross. Because there is at least one eigenvalue of this property. So that means right answer is only B is my correct answer. Okay, now you can see again what is the L. Again it's a boundary value problem. L is my 1 minus 0 is 1. So then lambda will be n pi over 1. Fine. So it is a n square pi square. There exists an eigen. So remember there exists for which the corresponding eigenfunction. So what is the eigenfunction? Y is equal to sine root lambda, that is a n pi x. Fine. N is my positive natural number. Positive integer, sorry. Fine. Now they are talking about the there exist. So can you find there exist? There exist. Can you find a there exist? Can you find a value of lambda so that this value does not changes over the domain 0, 1? Again, it's a simple. You can simply take n is my 1. Then what is my lambda? Lambda is my pi square. Solution will be sine of pi x. Fine. Whenever x belongs to 0, 1, this pi x will be my 0, pi. So my graph will be 0 to pi. The value of this will be here. Fine. Now can you find the y does not change the sign? What is the meaning of the y does not change the sign? It means y either always greater than 0 or always less than 0 on this domain. And you can see this case is y is always positive. Fine. This is my x, this is my y. So he said there exists. Yes, you can see there exists a lambda, that's a pi square, for which solution is always positive. That means it does not change the sign. Second case, is there any value of lambda exists so that it can change the sign? Yes, again, when it will be the change sign, that means either the positive or negative. If I choose n is my 2, then lambda will be 4 pi square. Then the solution will be sine of 2 pi x. Fine. So can you draw the graph of the sine 2 pi x? So it will be here. Fine. This is the graph of the sine 2 pi x. Fine. Now clearly say this case the value is my positive. Fine. While this case the value is my negative. So that means it changes the sign. This case is my positive, this case is my negative. So that means it changes the sign. Yes. There exists an eigenvalue lambda for which on the domain 0 to 1 is a positive. Yes, you can see this is my positive, their existence. Fine. Or you can take as n is equal to 1, this is a positive. Is there any value of this for which y is negative? Yes, you can extend them to be say 2 pi. Fine. Or otherwise you can see this case also. Fine. This case is also where value is negative. So yes, there is a negative. So all are my correct answer of this problem. You can scan and join my WhatsApp group if you want to finding more videos on this. Now look at the type second. What is the type second is, again we have the same problem. Up to the type 1 what we have discussed, this value is my constant. Fine. Now in this case we will discuss about when it is not a constant. Fine. Just like say y double dash plus xy. Fine. Y double dash plus x square y, or y double dash minus xy, and so on. So how you can think about what are the various shortcut tricks for such case? Number 1, if q is my positive and the limit of this x approaches is my greater than 1, then we always existence of the non-trivial solution first of all. Fine. And that non-trivial solution will have the property, that means the solution y and y dash has infinitely many 0 on the open interval a comma infinity. Remember, 0 is not include, or you can say on the positive x-axis. That's the meaning of the 0 to infinity, and this concept is very, very important. Fine. Look at that. If I compare this value with here, then we all know lambda should be greater than 0. That means q in this case is my lambda and it is greater than 0, is satisfied this property. Limit of this lambda as x approaches infinity, which is also greater than 1. Fine. Then y has infinitely many solution, and we already proved that it has infinitely many zeros. Fine. This is the first remark. Second, y and y dash are my non-monotonic. Why non-monotonic? You can see the same example for here, either sometime positive, sometime negative. And the last concept is the y and y dash limit does not exist, that means it's unbounded. Fine. That's the first remark for you. Second remark, whenever you have proof that this coefficient q is my continuous function, then if q is my positive, then you have at most finite number of the zeros. Remember, they have talking about the infinitely many zeros on the open interval, but they are talking about the closed interval. Whenever you have the closed interval, then you have at most finite number of the zeros. On the other hand, whenever q is my less than 0, then y dash have at most 1 0. Remember, this is whenever less than 0, at most 1 0, and in this case it is a finite number of the zeros. Now look at this concept, how you can solve this one. Firstly, I can write this equation in the simple manner, y double dash minus 1 minus x, y is equal to 0. Fine. Y of 0, y of 1 is my 0. Clear? So again, what is the L? Fine. So therefore this, now in this case this is my lambda, this number should be n pi over L square. Fine. Now that means this number is my n square pi square. Now look at the question. The problem has the non-zero solution. That means non-trivial solution. Fine. When it will be the non-trivial solution? When you prove that this q is my greater than 0. Fine. Because this number is always greater than 0. So that means this number should be greater than 0. That means this number should be here. Now x belongs to the 0 to 1. 1 plus x, when it has a non-trivial solution, when this number should be outside this domain. Fine. 1 plus x should be greater than of the 2. So lambda should be greater than 2. Then you have the non-trivial solution. For all lambda less than 0. Wrong. 0, 1 cross. 2 satisfied. And the value of lambda, as I already told you, all those eigenvalues, the set of the eigenvalues are my countable. And he also said a countable. So the right answers are C and D are my correct answer of this problem. Okay, look at this another one. Again, I can write this equation in this manner. Firstly, 4 plus x square over 1 plus x square, y is equal to 0. So this number is my qx. Fine. 1 plus 4x square over 1 plus x square. Now clearly say because of this square number, it is always greater than 0. Fine. So once this number is greater than 0, they are talking about infinitely many zeros. Infinitely many zeros. So what is the shortcut tip for you? Whenever you prove that q is my greater than 0, and if you find the limit and prove that it is a greater than 1. So what is the limit of this? If you take limit as x approaches infinity, this is 4, which is greater than 0. So therefore it has infinitely many zeros on the open interval, this one. So look at the option. Infinitely many zeros on the closed interval. Wrong. Whenever we have the closed interval, we have the at most finite zeros. Now you can see is a, I can, because 0 is the open interval, so it's a 1 comma infinity. So the B is my correct option. Now they are talking about the closed interval. Fine. So what are the cases? As I told you, whenever q is my positive, at most finite number of the zeros. You can see whenever it's a closed interval, so at most 3n is my finite, because n is my finite number. Because if I choose n is my 1, for example, fine, so then it's my 0 to pi. Fine. So it is a 3, that's a finite. On the closed interval, it is my at most finite. 3n is my finite number. So that option is also correct. Now they are talking about the at least. There is no result so far I have discussed for the at least. Now how you can check for the at least zeros? That's again a very simple. I have to use the Sturm comparison theorem. What is the Sturm comparison theorem suggested you? If you have the equation this, fine, make sure the right hand side should be 0. Consider the another equation, say p of x is 0, such that this q is greater than of the px or is equal to px. Then the number of the zeros of the q, or look at that, then if x0 and x1 are the two consecutive zeros of this equation number 2, then there exists at least 1 zero of equation number 1. Fine. This result will give the condition for the at least. Now look at that. What is my q is? 1 plus 4x square over 1 plus x square. I can write this equation as, if I divide them, it's a 1 plus 3x square over 1 plus x square. Now if I simply take equation is y double dash, which one is the easier solution? If I simply take y is my 1, fine, clear. Now you can see that this is my p, so q must be greater than of the 1. In this case p is my 1, fine. So what is the solution of this? It's a Sturm level problem. Y of 0 is 0, so the solution is my sine of x. Fine, fine student. Now you can see, can you find the solution of this over the interval? If I simply take n is my 1, 0 to pi, 0 to pi. Remember, it's an open interval, there is exist. So how many zeros exist in the closed interval 0 comma pi? Remember, this 0 does not exist, only 1 0 here. It is always with the open interval, fine. So only 1 0, fine. So at least 1 0 of this. If you consider as n is equal to 2, that's a 2 pi here. How many zeros occurring? 1, 2. Always remember, this is the open interval, so 2 zeros, so at least 2 zeros, fine. If you consider as a 3 pi, the graph of this will be here. How many zeros are there? 1, 2, 3. So it's a 3 0. So yes, this option is also correct. So B, C, D are my right answer of this problem. Okay, look at this another one. Thus again it's a boundary value problem and eigenvalue related. So firstly I can simplify this, and you can see this is a very recent paper. Y double dash lambda minus 3 of y is my 0. Then has a non-trivial solution. The first case is this number should be greater than 0, fine. And second case is, because this case is given to you, L is my pi, so the lambda will be lambda minus 3 is n pi over L. So that means lambda minus 3 should be n square. So first of all, the lambda should be greater than 3. So these options are cancelled, fine. Now from here, n is my positive integer. So what is the value of this? You can see 3 can never be possible. 3 is only possible because it's a strictly greater than 3. So this option is also cancelled. Only option left behind is here. If I choose n is my 1, then lambda will be 4 is the right answer. Can, if I say the option is 5, is it possible? No, because there is no value of the n, so that the answer is 5. Fine. Okay, look at this another one. Y1 is the solution, non-trivial solution of y double dash plus xy is equal to 0 when x lies between 0 to infinity. Y2 is the solution of y double dash plus y is x square plus 2 such that y of 0 is 0, y dash of 0 is 0. Has infinitely many 0, infinitely many 0, finitely many zeros. Fine, very simple. Whenever we are talking about the finitely many zeros, we are look about the closed interval. Whenever we are look about the infinitely, we open interval. Fine. First of all, right hand side is 0. When it occurring the infinitely many solution, when this q is my greater than 0. Fine. Now you can see this number is my greater than 0. So that means this that is a y1 has infinitely many zeros on the open interval of 0 comma infinity. So y1 has infinitely many zeros, correct. Y1 has finitely many zeros, wrong. Fine. Now look at that, y2 is the solution of this. Now if you think about that, this condition is given, then you can find the value of the lambda like n plus half whole square pi over L, but that is not true. For that, when this case will be applicable only when the right hand side is 0, but this is not 0. Fine. So then you can't apply them. Now what is the q? in this case q is my 1 which is greater than 0, satisfied, but right hand side is my non-zero, so you can't directly say y2 is infinitely many 0 or finite. Can you find a one solution? What is the complementary solution is m square plus 1, so m will be plus minus iota, so y is c1 cos x plus c2 sin x. Fine. How you can find the particular solution? So it will be 1 over d square plus 1 of x square plus 2. So I can do that. 1 over d square is outside. 1 minus 1 over d square is x square plus 2. Fine? No. It's a d square plus 1. So you can directly use this. I can open this one. 1 plus d square of minus 1 x square plus 2. So I can use this binomial because it's a quadratic, so there is enough of that. Fine. So what is that? It's a x square plus 2 minus what is the second derivative of this 2? 2 will be 0. So the particular solution is my x square. So what is my solution? So y2 is my c1 cos x plus c2 sin x plus x square. Now this case is given to you, so that means the solution is in the form of the sin x. So c1 will be 0. When you substitute y dash of 0 is my 0, that means c2 cos 0 is 1 plus 2 times 0 is 0, so c2 will also 0. So my solution will be x square. How many zeros are there? It's a finite zeros there because it's a quadratic equation. So quadratic equation has only 2 zeros, so it has finite 0, no 0. Make sure whenever you apply the concept of the infinitely many 0, right hand side should be 0, but in this case it is not there, so you have to find the solution. Okay, then again it's a non-zero solution. X double dash plus e of t square of x. Fine. So this is my q. Clearly say exponential part is always be greater than 0. So that means this has, because they are talking about the x of t is 0, that means they are talking about the zeros. So it means it has infinitely many zeros on the open intervals 0, infinity. So that how many zeros are there? That's a cardinality. 1 not possible, 2 not possible, greater than or equal to 2. Yes, I can return this number is my 2 to infinity, positive x-axis, 3 to infinity, positive x-axis. So the right answers are my B and D are the correct answers. Okay, look at this another one. What is given to you? Y double dash minus q of x, y is equal to 0. Y of 0 is my 0. Y dash of 0 is my 1. And q is my positive and increasing function. Now, then, if you look about that, if you compare this differential equation by here, make sure it is a positive, right hand side is 0. So that means if I look about here, I call this is say my px, then what is my p is minus of qx. Fine. So then because q is my positive, so this means this number is my less than 0. Fine. So that means what does it means? If q is my less than 0, remember what is the case for that? Whenever this case is here, q is my less than 0, that means there exists at most one, what is the shortcut text as I gave you? There exists at most 1 zeros. Find y dash has at most 1 zeros, but he said infinitely many zeros cancel. Infinitely many zeros only when this number is my greater than 0, but this number is my less than 0, so infinitely many zeros cancel. Fine. It has finitely many zeros. Look at the word is many. but we have a at most, that's a finite, but he said many. Cancel. Fine. Now y is my infinity, y dash is my infinity. That means y is my increasing function. Can you prove that y is increasing? How you can prove the y is increasing? That means y dash should be greater than 1 at the critical point. Fine. How you can find the critical point? So you can see this is given to you. Y dash of 0 is my 1. So this 0 is my critical point. Fine. So y dash is my 1, which is greater than 0. Sorry, y dash is greater than 0. Then we can say it's my increasing. So y dash is greater than 0. That means y is my increasing. So once y is my increasing, so that means this is my here. Look at this one. Now I have to prove y dash is increasing. How you can prove that y dash is increasing? For that you need to prove y double dash should be greater than 0. So I can check about here. This is given to you. Fine. Now at x is equal to 0. Y double dash 0 minus q of 0, y of 0 is 0. So what is the value of the y of 0? Y of 0 is my 1. Q of 0 is a positive, so it's a non-zero. Y double dash at 0 is equal to Q of 0, and this is my positive, which is greater than 0. So that is y double dash is greater than 0. That means y dash is my increasing function. So that means this is my here as x approaches infinity. So A and B are my right. Okay, look at this another one. Y double dash plus xy is 0. Y of A, y of B is my 0. So what is the L? B minus A. But can you say Q of x, in this case x is a greater than 0? We can't say that because we have the unknown values of the A and B. Very simple. You can choose any of the A. X belongs to this. I can choose A is my minus of pi, B is my pi. Fine. Why I should have taken? So that my interval x belongs to this. Fine. And this problem I can change to here because 1 belongs to this. Fine. So my equation becomes my here y of minus pi is 0, y of plus pi 0. Fine. I can simply take these examples. Now can you find the solution of this? Solution is my sine of x. Clear? Now once y is equal to sine x, y, you can see firstly y dash of A is 0. What is the y dash? Is cos x. Y dash of minus pi is non-zero. So this option is cancelled out. It has infinitely many zeros in infinitely many zeros. This is only possible when q is my greater than 0. But you can see when I take A is my minus pi, 2 plus pi, does it always greater than 0? Q of x is x, which is not always greater than 0 on this interval. Y is monotonic on minus pi to 0 whenever this problem satisfied. Okay? Then y is monotonic. So you can see sine x is my monotonic in this interval. What is the graph of this? Sine of x minus pi to pi, this one. Fine. You can see this is a monotonic function. So yes, this is correct option. B is my positive. That's the correct option. So A and B are my right. Okay, look at this another one. Y1 and Y2 are my fundamental sets. What is the meaning of the fundamental set? Y1 and Y2 are my LIs. Fine. So once it is Li, that means Wronskian of Y1 and Y2 is my non-zero. P and Q are the real value continuous function such that x0 and x1 are the consecutive zeros. So y1 of x0, y1 of x1, it is given to you as a 0. Then y1 is my here, y2 is this, y2 is this, and y2 is this. I can start from this fourth option firstly. This is 0 and this is non-zero. Remember, in the given statement, they are talking about the fundamental set. That means Li. What is the Wronskian of this? Y1 and y2 will be y1, y2, y1 dash, y2 dash. Now, at the point of x naught, what is the value of the x naught? Y1 x naught, 0. Y2 x naught, if I assume this number is my 0, y1 x naught we don't know, y2 x naught we don't know. Fine, it is a non-zero, so let's say this is a 1. So if it is a 1, what is the determinant of this? 0, but we need a non-zero. So if this condition happen, it means y1, y2 are not Li. Fine, but it is already given that this is Li, so this option is cancelled. Now look at this second option. Y2 has no 0 in x2 and x1. Y2 has no 0 in that is again a very simple. You can simply take y1 and y2 are the fundamental solutions. I can simply take p is my 0, q is my 1. This is my solution equation. So we all know the solutions are my sin x, solution is my cos x. So I can choose any two consecutive 0. A I can consider as a 0, this consider as a 2 pi. So y1 I can consider as a sin x over the domain 0 to 2 pi. So you can see over the 0 to 2 pi, this is the graph of 0 to 2 pi. Fine. x0 and x1 are the consecutive zeros. This is my x0, this is my x1. y2 has no 0. Can you say y2 has the no 0? Okay, this example is fine. If I change them to be the minus pi and this is plus pi, fine. So then what is the graph of the cos x? Cos x will be here. Fine. So you can see this value pi by 2, add the value of the pi by 2, it has a 0, but he said no 0, so this option is also cancelled. Fine. Look at the B option. y1 this, where p of this. So if y1 is my here, again I can check at the point x naught. y1 is 0, y2 we never know. Fine. y1 dash, what is the value of the y1 dash at the point x naught? Is a 0. What is the value of the y1 dash? 2 times x minus x naught of p naught x. So clearly say this is 0, and whatever the value of this, what is the determinant of this? Again 0, but we need a non-zero. This option is again cancel out. Fine. Now look at the first option. Again this number is my 0, y2 of x naught. What is the derivative of this? That is my q0 of x naught, and this number is y2 of x naught. Now it is given that q0 of x naught is my non-zero. This number is my non-zero. This number may be 0 or may not be 0, but you can see the determinant is non-zero. So that means these are Li. A is the only right answer in this problem. Okay, look at this another one. y1 and y2 are the fundamental solutions of this p y dash plus q y is equal to 0. Then p and q are the continuous. Okay, I can simply choose p and here. So what is my equation? Fine. So what is my solution? There are the two solutions. One is sin x, other is cos x. Now both y1 and y2 cannot have the local maxima at the x naught. Again, is a fundamental, that means they are Li. So again, I can start from this case. y1, y2, y1 dash, y2 dash. So both cannot have a local maxima. What is the meaning of the maxima? That means the first derivative at the point is 0. So you can see, if both cannot have, assume that both the values y1 and y2 have maximum at the point x naught. That means this number will be 0 at the point x naught, y1 x naught, y2 x naught. If it is a maximum, it means the derivative will be 0. So the determinant is a 0. That means it is not Li, but it is already given that it's a Li. So it's a cannot. Yes, they can never be. Both y1 and y2 cannot have a local minima. Again true, because if it is a minima, then it is not Li. He said cannot. Yes. y1 cannot have a local maxima. That means this number is my non-zero. y2 cannot have a local minima simultaneously. Yes, again that's correct option. Again by the here. Both y1 and y2 cannot vanish at the point simultaneously. That's true again, because if both are vanish at the same time, then Wronskian will be here. So this will be 0. Again, it's a not Li, so that's why it's a cannot be possible. Yes, it is possible. All are my right answer of this problem. Okay, look at this another one. U is the positive eigenfunction of u double dash plus 2u dash plus a of t minus lambda, because remember right hand side must be 0, and this is u dash of 0 and u dash of 1. A is any continuous function of this, which are the following value of here. So firstly, check whether lambda is 0 or not. How you can find that? Because it's first of all, it's a Sturm level problem. That's fine. Okay, can you find the solution? That means your target is to find the u. I can write the auxiliary equation, 2m plus a minus lambda is 0. So my equations are minus b plus minus b square. B square will be 4 minus 4ac divided by 2. That means minus 1 plus minus 4 will be cancelled out. 1 plus lambda minus a. Fine. Now, first of all, it's a positive eigenvalue. Fine. Now, but it is not. Now it is not an eigenvalue. How you can think about that? Firstly, see lambda is 0. If lambda is 0, this number will be 1 minus a, and a of t. This basically a is my a of t. That means here 1 minus of this is always my, what is that, 1 minus a is always my positive number. Fine. So once this number is my positive, how you can say lambda is 0, then 1 minus a, 1 minus, how you can say about that? I just checked the question paper and it is given as a 1 instead of here. Now if it is a 1, then what is the value of the 1 minus a? Because a is always be greater than 1, so this number will be my negative. That is a complex number. So but eigenvalues are always the real, so that means whenever lambda is 0, this number is my negative, so it's a complex number. That is not possible. When lambda is my less than 0, so you can choose any number, say minus 1. Fine. When lambda is my minus 1, this number will be my minus of a. Fine. This number will be cancelled out, so it is my minus of a. Again, it's a complex number which is not possible. Take any value of the lambda which is greater than 1, say my 1, so it will be 1 plus 1, 2, 2 minus a. It is always positive. Fine, because a is my greater than of the 1 to infinity, so you can choose them. Otherwise, You can think, because lambda is my positive, 1 minus a plus lambda. Fine. 1 minus a is my positive, lambda is my positive, so this number is always positive. So that means you have the real root. So that case is possible. Now look at this third case. Now if you look about that, that's the integration. And if you look about this u into u dash, a of u square. So that means I have to multiply this term by of this. So the left hand side, u double dash of u from 0 to 1 plus 2 times u dash of u plus a minus lambda u of dt from 0 to 1. So you can see there is no need to solve this u square. Fine. There is no need to solve this. Fine. I have to only solve this part. So I can solve this by parts. First function, second function. Or I can simply take this is my first function, this is my second function, so that I have to integrate them. So what is that? First function, integration of second function. So integration of this is my y dash from 0 to minus derivative of the first function u dash, integration of the second function u dash square, plus rest of the function are similar. Now what is the value of this? Now you can see u dash of 0 and u dash of 1 is my here. So this number will be 0. So only thing is minus 1 to 0 u dash square plus 2 times u of u dash plus a minus lambda u square. And you can see this negative I can put on the right hand side, you will get the same answer. So the right answers are A and C are the correct options. Okay, look at this another one. The boundary value problem of this has the unique solution. Again it's a boundary value problem. What is the Sturm level condition I have given? This is the lower limit 1. So that alpha must be less than 0. Fine. And that beta must be positive. So alpha is a negative, fine. Beta must be positive. So second option is directly cancelled. Now it has a unique solution. First of all, can you solve this? Clearly say this is my Cauchy-Euler equation. Fine. So what is the solution of this? M square plus minus 2 minus 1 plus of 2. So it will be m square minus 3m plus 2. So m will be 2 and 1. So the solutions are, one solution will be x square, second solution will be x raised to power 1. Now it has a unique solution. When it has a unique solution? When this determinant should be non-zero. So what is that determinant? That means this number corresponding to x square, this number corresponding to x raised to power 1, that's a x. So firstly I can say x square, it is my 1, I can write here 1 plus alpha times first derivative, what is the y dash is 2x. So what is the value of this is 2 times 1 is 2, so 1 plus 2 alpha. Same value for here, x square, that's a 4, y dash of 2, that's a 4 beta. Same for the y2, that's a x, 1, derivative is my 1, so 1 plus alpha. For this 2, derivative is my 1, so 2 plus beta is my, because whenever you have the system ax is equal to b, for the unique solution you must have determinant of a is a non-zero. Now look at the option 1. When alpha is equal to minus 1, this will be my minus 1, this will be my 0, beta will be 2, so 8, 12, beta will be 2 is a 4. Clearly say that determinant is non-zero. So first option is the right answer. Look at the third option. Alpha is equal to minus of 2, so minus of 2 minus 4, minus 3, minus 1. Beta is equal to 2, 12, beta is equal to 2, 4. So minus 12 plus 12, 0. So this option is cancelled. Look at the third option. alpha is equal to minus 3, so minus 6, 5, minus 2. Beta is equal to 2 by 3, so it is 4 plus 8 by 3, so it's a 12, 20 by 3, and 2, that's a 6, 8 over 3. So what is that determinant is? Minus 40 over 3 minus minus plus 40 over 3 is a 0. So this option is also cancelled. Only A is my right answer. You can also check about the second option if you want to see, like here alpha is minus 1, 0, beta is minus 2, so minus 8, minus 4, it is my 0. Again you can see that determinant is 0. So the right answer is only A is my correct answer. Okay, look at this another one. Again a boundary value problem. Y double dash plus y is cosecant x. So clearly say lambda is 1. So the solution will be sin x. Fine. Or otherwise, if you don't understand it, you can write it as complementary solution is c1 cos x, c2 sin x. How you can solve this part? I can use the variation of parameter method. Fine. So y complement is minus y1 y2 r over Wronskian plus y2 y1 r over Wronskian. This is my r. What is the Wronskian of the sine and cosine? It is always 1. So it is minus cos x. Integration of y2 is my sine into r, 1, plus sin x. Integration of cos x, cosecant is my 1 over sine, r is my here. So what is the answer of this? Minus x cos x plus sin x and log of sin x. Fine. This is my yp. Then if you apply the initial conditions, you will get c1 is my 0, c2 is my 1. So your solution will be sin x minus x cos x. Okay, y of 0 is 0, so 0, sin 0 is 0, sin 0, c1 is 0, fine, plus sin x log of sin x. Now add the pi by 2, left hand side is 0, c2 is a 1, this is cos pi by 2 is my 0, sin pi by 2 is a 1, log of 1 is my 0, so c2 is also 0. So finally your solution will be this one. Fine. Now you can see whether it's a convex, concave, negative or positive in this domain. So firstly we can check about the positive and negative. That is quite easy. On this domain, fine, this number is always positive, this number is always positive, so the whole quantity will be my negative. Sin of x when x lies between 0 to pi, it is my 0 to 1, fine. Whenever this number lies between 0 and 1, so log of sin x is always less than 0, that's a negative number. This number is always positive, this number is always negative, so product will be negative. This part is negative, this part is negative, so that means this number is my negative. Fine. Now the only thing is whether it's a convex or concave. Fine. Now what is the property of the convex and concave? Y double dash should be greater than 0, y double dash should be less than 0. That's the only thing you have to need it. Now what is the endpoints are given to you? 0 and pi by 2. I can check the values at here. Plus y of 0 is cosecant 0. Cosecant 0 will be infinity. Y of 0 is my 0. So y double dash of 0 is my infinity, which is positive. Fine. So that means at x is equal to 0, whenever y double dash is greater than 0, that means it is my convex. Now we can check about the endpoints pi by 2. So what is that? Y double dash of pi by 2 plus y of pi by 2 is 0. Cosecant pi by 2 is my 1. So y double dash pi by 2 is my 1, which is greater than 0. So therefore y is again convex at this. So this is convex at here, it is convex at here. So that means it is convex on this dome. Otherwise, second method is you can find the second derivative of here, and you can prove that it is always greater than 0, as I proved as this one. And it's very simple, you can easily prove that y double dash of this. So let me okay, I can verify for you. What is the y dash? Is a minus cos x plus x sin x. What is the derivative of this? It's a cos x log of sin x plus it will be sin x 1 over sin and cos x. Fine. So this number will be cancelled out. It is here. Now you can find the second derivative. It is x cos x plus sin x, then minus sin x log of sin x, and it's a 1 over sin into cos. So 1 over sin into cos is a cos square over sin x. Fine. Now if you take the LCM, it's a sin square plus cos square is a 1. So x cos x plus 1 over sin is my cosecant x minus sin x log of sin x. Fine. Now you can see over this interval, this number is my negative. So this negative, it means this whole term will be my positive. Cosecant on the first quadrant is my positive. This number is my positive. So y double dash is my positive. So that y double dash is positive means it's a convex function. So this is the way you can solve this boundary value problem, simple manner. You can scan and join my WhatsApp group too. I hope you can subscribe my channel. You can share this video with your friends. Best of luck, students. Happy luck.